in this video, I'll be talking about an introduction to machine learning and topic modeling. For the contents, I will be talking about first about data mining and data analysis, so machine learning, deep learning, and topic models. So let's get started with data mining. So what is data mining? Well, basically data mining is when you have a vast amount of data and you're trying to understand that data or do something to that data. So basically describe it or trying to automate something using that data. Let me show you, let me show you the stages of data mining. So the first step of data mining is problem specification, and then the second step is problem understanding, which I think both these two steps are self-explanatory. Problem specification is basically that you have to specify something before you start, like what are you going to do with that data and what task you want to do with that data. Problem understanding is basically read previous work, do something that don't do something that has been done before, understand what you're doing basically, and see if other people have done half of the work, for example, then use that work to do some, and then develop it to extra work. And then we have data pre-processing, which I will talk in the next slide, and then data mining, evaluation, and then results exploitation. So evaluation and result exploitation. Evaluation is basically when you create a model, after you train it with the data, you have to evaluate the model to see if actually the model is doing good or that your data mining application is doing good. So let's jump to data pre-processing. So as you can see here, the data pre-processing is basically when you clean the data, when you change the shape of the data from one shape to another. For example, we have data cleaning, data normalization, data transformation, missing values imputation, data integration, and noise identification. So for example, in this here we could have, for example, an image here, and then we change the image with too many pixels. But we change the image to a certain size of pixels. So we change all the images in that data set to one single size of pixels. So that's here data transformation. Or if we have text, for example, let's say we have a set of sentences, and then we set the size of the sentences to a fixed number. And then for example, the sentences that are small, that fixed number we set, then we should pad the sentence with empty words so that it fits the fixed size. Data integration is basically when you have two different types of data and you integrate them into a bigger set, and then you will basically use that for your data application. Data normalization is when you normalize the data. For example, you have a smaller shape, and then you have a medium shape, and then you have a bigger shape, and then you change it to all having the same shape. So that's the same example I gave before to sentences or images. Imagine images having all of the images in your data set have a different pixel sizes, and then you change them to a single pixel size. Or let's say you have numbers in your data set, and these numbers, they vary. For example, from 0 to 100, and then you change that from 0 to 1. So that value is more fixed or better. It's better to understand that value than reading like huge values like in millions or something like that. And then missing values imputation. Missing values is also self-explanatory. Is when you have missing values inside your data and you have to deal with that. I wouldn't say it's efficient, but one common way to do that is probably use like a mean of the value. For example, if you're missing the price of certain houses, if you have the house data set, if you're missing some values in the price tag, then you could like use the mean value to fill that up. And then noise identification is when you have, for example, data. And then you have noise identification when I said like when you have like, for example, data that doesn't fit the norms of the other data, and you just clean it. You take it away from, you take it off the data, and you don't use it. You use the rest of the data, but not that specific part of that of the data. Now we're done with data pre-processing, and you'll see if you practice more with with data mining or machine learning, you'll get to know more and more about data preprocessing, and it is a very, very essential part of machine learning and data mining. So now I will talk about data mining methods. So basically, data mining methods are split into two branches. So we have a prediction branch where we use it for automating data. So, and then we have description. So both these tasks are different. One of them is to understand the data or to see something into the data. Sometimes you want, for example, to, as you can see here, clustering. You want to see clusters inside the data and you want to understand it better. And here you have prediction, where you want to predict the future values or future events in your data. So in clustering, we have, I think it's self-explanatory. You have data, you have points into your space, and you put them into different groups. For example, let's say we have a set of articles, and then you cluster them into groups of topic. Like it depends on, like, let's say politics, sports. Then these are different clusters. And then we have association rules. There is a very famous example easy example to explain association rules. So think about, like, for example, going to a supermarket and you buy burgers, and then you buy let's say no, you're not buying burgers. You're buying ham, and you're buying lettuce, and you're buying stuff like that you make a burger with. So with that, you make obviously you'll make a burger. So what here you could build association rules from that data. And then with those association rules, you could predict future later. It can be used for many things. For example, if the supermarket can advertise its products depending on what you pick. For example, if you pick the ham, you pick the beans for the hamburger, and then you don't pick Coca-Cola. So that supermarket can advertise that for you at the end, and then you'll see that and you're like, oh, I almost forgot that. So that's a good way to use association rules. But here is just to understand the data, and that's why we have the association rules. So the second part, which is prediction, is predicting the future. We have statistical models, which is also partly machine learning. This is the machine learning part, and this is also a machine learning part. But this whole branch is machine learning. But we have here rule learning, which is the old system on how to do rule-based learning. It's basically just if, else, as you can see in the picture. I don't know if you can see it, but it's if, else, and you get to a result. So basically, you could, for example, if you did this, then do this. If you did that, then do that. So basically, you have rules that end up with some kind of decision at the end. Decision trees are similar, but they are more developed into a tree. So you'll have, like, for example, values. You'll have, and they also build themselves up after you give the data. So you can, we have decision tree algorithms that can build from the data just by applying them. And then we have statistical methods such as regression models, neural networks, Bayesian learning, instance-based learning, super vector machines, and so many other algorithms out there that I will not be talking about. But I will be giving an example about regression models. I'll be talking a little bit about neural networks, and that's it. So if you want to learn more about statistical models or machine learning in general, then I advise you to go and look up more, better and more tutorials.